the variation from herbs, shrub, trees, and like that is so huge. And regarding in the Poaceae family, tackling them is a bit easier in the sense that the plants are small, you can keep them in small places. Like once you collect if you take your polythene bag, go to the field and work the whole day, you can come up with a lot of species. But this is not the case with larger trees. So for me, the thing was the tackling this in Poaceae was easy. And probably that might be the reason that I was like, I liked grasses.
Of course, yeah.
And more, and one thing more. Like they are cereals and we feed on cereals. So I think Poaceae gives us maize, wheat and rice, and so it is the most, economically the most important family, and we need to work on it.
Yeah, so regarding all the questions regarding the difference between the size of C3 and C4 grasses, you mentioned it needs to be applied in paleoecology to see on sediment cores, the difference of the sizes along the time. Which area would you suggest to do that?
That is the question, because my area was previously not worked. Like there is one paper from 1999 where they worked almost some 3,500 kilometers north of my area, and their aspect, they focused on some animal remains, and that my area was my study was the first in this in the Hindu Kush and Himalayan region here. So I had no clue for that. So when I went to the field, I thought.
Actually, I mean not only in maybe
I'm answering your question, like which area would I use? Like I thought, because here we worked in Europe and collecting the samples was too easy. But when I went to my home area, there I had a lot of problem. The whole month I spent in the field, because I had Russian coral, the soil was so hard, compact, and drier. Like we broke the Russian coral there in the field. Two of my colleagues were with me. We spent the night there in the field. Then we brought laborers to help us, and even then our coral broke there. So this is a question for me. Like I'm interested in my own area, but the thing is that regarding the very basic work of taking core from the area becomes a limiting factor for me in terms of the equipments.
Yeah, but I mean not about the difficulties to get a core. I mean areas where you could apply another method to see if you have changes between C3 and C4 grasses over time. So would you apply that here in Europe or in another area?
Yeah. For the time being, I am a person from South America, from Brazil, has seen my paper and has contacted me, and we are now interested to share our data. So my next interest is that we should compare the Hindu Kush Himalayan region of South Asia, my research area, with Brazil, with South America. So I'm increasing the number of species also on one hand, and on the other hand, this will help me go further into.
So you think South
Yeah,
America?
Yes, South America is my like, and that is the possibility for me to, considering the various aspects of financial and other things, like that is a good option for me to, like we will be sharing data, and it's a big fun if you
Okay.
get all the data.
Now time is running and there might be still more questions. So, yeah.
Do we have time? Yes, then I would like to look at figure 32.
On slide 32.
Yeah, because just shifting the topic, and the application. I mean, this is what I'm used to see when I'm here. Yeah. But you know, I come from forest ecology, and so I would like to have some more explanation on Thymus, Picea, Avies. I mean, you mentioned, these come from the surrounding mountains. When you explained the increase in pines and so on, as far as I understood, you interpreted, the grasses were here and there and blah blah and so on. And then later, the pines and so on came in. And then the pines, you say, are found along the hill slopes and so on. So, can you please, just for me to understand the forest dynamics of the area and the interplay with non-forest vegetation, find some more words on the trees and the grasses and how they interact in the area.
Yeah. So if we look at around 3,300 years before to 2,400, here we can see that the conifers are very less, but the herbs are dominant in the area. So if we are interested in looking at the interplay term which he used regarding the vegetation on the landscape, so here this shows that the landscape is quite open and majority of the vegetation is herbaceous because the conifers are very less here. But if you look at the modern time, here the conifers have quite spread in the area. You can see the peaks here, especially for pines, which shows that the climate, the modern climate as compared to the previous one, is much wetter, because this is also, we can see at the other trees and shrubs, they are also larger in the landscape. And here also, looking at the Poaceae peak, it has quite decreased here, which shows that the grassland is squeezing, like the grassland is decreasing and the conifers are increasing. So the modern composition is that like conifers have spread in the area and grasslands have squeezed.
I would like to ask the same topic. So I would suppose that the study area is quite densely populated by men.
Yes.
So
it is not that dense, but there is a village. The coring side is a village. On one side there is a river, and on the other side there is a population. Yes.
Yeah, but I would suppose that there must be human influence on the forest. So this usually means deforestation and not increase in species. So is there some human impact causing the increase in conifers?
Yeah. So the Palynological study has not been previously conducted, but the vegetation people are there, and the conservation people are also there, and this is already reported that there is illegal smuggling of wood and deforestation because the laws are not that strict. So that is already reported. Yes, but here the results of my core shows that they have spread in the area. The conifers have spread in the area, but this does not mean that deforestation is not occurring there. This is then another issue.
Could pine be replaced maybe more natural forests as a response to logging activities, that you have more pines? Is it just the climate or also planting?
Can you please repeat your question?
The increase in pine, is it really just due to variations in climate, or is it also a response that pine replaces maybe deciduous forests because the deciduous forests develop?
Well, it is already established pine is abundant pollen producer.
Yeah, sure.
And in the research area, I myself belong to the lower plains, which is quite disturbed. There is urbanization, and there are very less pine in the plains down. But I had signal of pinus pollen even in the plain samples from in my other study of vegetation pollen relationship. But the pinus being abundant pollen producer is showing the maximum peak that it has spread in the area. I think that it might be the reason that due to global warming in the recent time the rains have increased, and probably that may be the reason that along with other pinus and other conifers, the trees and shrubs have also spread in the area.
It means
And
it's
another
went up in elevation? Or because if a species spread, why should pinus spread more than quercus, for instance, due to climate warming?
I think that maybe that pinus is abundant pollen producer. Maybe that may be the reason.
Referring to your findings or to your interpretation that the results that you show here are chiefly due to the climate change or climate signal. Is there any, and not so much to the human impact, is there any other evidence apart from your findings that there has been such a climate development over the times and fitting into your patterns, into your findings, apart from your own study?
There is a study which has been conducted, but that the focus was not paleoecological, that was more archaeological. And my findings of about the conifers from this 2400 to 1500, I found a little similarity with that work, but I think I didn't find much. I didn't find papers on my area. There were already 2 studies conducted near to the area, but the focus was not paleoecological. Just I mentioned one was archaeological, and the other paleoecological work which was conducted was further towards the Tibetan plateau of China. So I could not find other results to tally my results with that. So I think to my information, my study is the first in this area.
Yes, I realize it's the first, but is there any from other
evidence
from other kind of studies? Yes, is there any evidence to support your findings? Because for me, I'm a little bit in doubt about referring this result that you show us here so exclusively to the climate signal, because I realize your area is an area that is inhabited and populated since millennia, and there should be some anthropogenic impact that is also visible in such a pollen diagram.
Yes, so what's the question?
The question would be whether your results do not so much show the climate signal, but the man-made signal.
Yes, but but we cannot ignore the anthropogenic aspect. But for that purpose, we normally do additional analysis, charcoal analysis, which I haven't done, and that gives us more regarding the fire frequency, and that gives us more information, but that I haven't done. I have solely worked on the pollen. And regarding
I actually think that fire is important as a human impact in this respect, because the people that lived there over centuries and millennia, they were probably not so much interested in burning down everything that they could get at, but use it, make use, for instance, of the woodlands. And would that perhaps explain a little bit of the patterns of change between the proportion of deciduous trees, conifers, or different tree species? What do you think? Is it possible?
There might be other, but your question was why fires. Your initial question was why fires act as a signal. Like why should we use fire as a signal of anthropogenic impact? So that's what I'm aware of. Like from my paleoecology field, I'm aware of that where humans are, they make burning activity for their consumption. And regarding other aspects, I haven't thought much about it. I should.
And that's also common that regarding your studies, I understood that the study site here is in a protected area, and it's so far little disturbed by human activities. There's some present day, some illegal logging going on, I understood, but in general it's a protected area, isn't it?
Yeah, it's like away from the human population, but in the surroundings of the valley there is human population, so I cannot negate the anthropogenic impact. It might be. Like, and the illegal logging, like that is also reported there. So the human impact is there. So,
but not that strong, compared to the lowlands where our studies are thinking.
yes, in the lowlands, the impact is far less as compared to the lowlands, because the lowlands are very less urbanized, and the grasslands where I have worked, there are secondary grasslands. Because the primary grasslands have almost vanished.
Yeah. Yeah, time is running. That's the question from the
addressing the ecology of C4, you stated that increasing elevation along the gradient, the number of species and the amount of C4 is decreasing, and you stated that C3 is preferring the cooler climate, while the C4 are more present in the warmer climate conditions, so in the lower elevational areas. My question addresses, why is that so? What is the ecophysiological background of C4 plants that they have that advantage in the warmer climates, typically tropics and subtropics, and why do they not spread towards the cooler climate? What is the ecophysiological basis for that?
Well, to the like here is a data set from biotransit, and here this PCA shows that based on the 4 pollen gland parameters, the pollen gland length, the width, the core diameter, and the thickness, the 2 prominent parameters here, they show increasing trend for polyploidy and C4, species, and if we look at the elevation here, these are the elevation in meters. These elevations, the transit is from 275 up to 2,600 meters. So there is a mixed trend of, like here are deployed and C3 species, but if you look at the elevation range 1950, 2050, 2,480 meters above the sea level, though there are some 730, 1,256. So C3 species are mostly at C3, and deployed species show more trend for higher elevation. And polyploid and C4 species, based on the measurements of the polygram parameters, show trend for at lower elevations. There are elevations where they show mixed trend, like 850, 950, 730, but there are elevations which show that C3 species are more at higher elevations than C4 at lower elevations. Number one. Now come to your question. This is already established that C4 grow at lower elevations and C3 prefer cooler and higher elevations. And so from my data, I have the already established trend is satisfied in my data set from Pakistan, not from other species, because this is the PC only based on the 70 species. Regarding the physiology, like I haven't looked into that aspect. I should look into like the C3 pathway and the C4 pathway. What might be the reasons involved? But frankly, I haven't looked into the physiological aspects. I haven't looked much into like what might be the role of like C3 pathway or C4 pathway.
So I have one question. If you don't know about the physiology of C3 plants and C4 plants, which is actually quite trivial, what was then your motivation to do your study? Because if you know the background, the different functioning of C3 and C4 plants like we do, then it makes sense to conduct this study. But if you don't know, then I don't understand why you did your study.
As I told it is already established that C3 species prefer cooler climate and higher elevations, and C4 species prefer warmer and lower elevations. Okay, if this is in the information from what the field experts say, then I as a palynologist can use this information of this already trend of distribution of C3 and C4.
Then the study is superfluous because the elevation didn't change along a period of 3,000 years or so.
Yeah, but physiologists do not classify